So this is what we have done for the phase 2 lab number 3. So now we'll try to go to phase 3 for this. In phase 2 we determined all these conversion factors and we got the inclination angle as well. So now let's we go to phase 3, and for the phase 3 it's basically for the track motion of the mug. So click near upper left edge of the mug. So we are going to click here. Now record the frame number along with the X and Y pixel coordinates of the last measurement in the lab data. So on this left hand side, if you see, you have the video information that this is the total duration that took for this motion. You have frames per second, current frame is 14, and these are the last measurements. So now we'll go to our lab data. Here we have, and the moving mark, the T frame. So the last measurement we have for this is 10. Horizontal position, the X pixels we have 1, 1, 0. The vertical position, Y pixels we have 4, 0, 8. So this is we have, so we got the check mark on the second point. Now it says convert frame to time. So convert frame to time and record in lab data to 4 decimal places. So frame to time. So for that, what we are going to do, we have already the time per frame, which is the time per frame is our 0.0167 seconds. So time for our frame number 10 is going to be 10 multiplied by this number 0.0167. So when you will multiply 10 by this, we will get 0.167. So this is going to be the time in seconds, and we got this check mark, so this is good. Now it says convert both the X and Y pixel coordinates to the centimeters and record in lab data to 1 decimal place. So now we have X in pixels and we do have the conversion factor of 1 pixel to the centimeters. So 110 pixel to in centimeters is going to be 110 multiplied by this 0.0634. So when you will multiply this number, we will get 6.974, and since we need it to 1 decimal place, you're going to put 6.9 is going to be our 7. So we got this number as 7. And next, Y pixels to centimeter, 408 pixels. So 408 multiplied by 0.0634 is gonna be our 25.9. Okay, so we got these numbers. Now take this down, click near upper left edge of the map. Upper left, so we are gonna click here again and record the frame number and both the X and the Y pixel coordinates of the last measurement. So again take this, your data table, come here. Now our frame number is 14. The pixel X is 1, 2, 3. The vertical position is 405. So we got this, and record the frame number, both X and Y pixels. So we got this check mark. This is done. Now convert frame to time and record in the lab data to the 4 decimal places. So you're going to do the same thing again. The 14 multiplied by this number, same 0.0167, and you will get 0.2338. So this is done. Now again convert both X and Y pixels to the centimeters. So same thing, 123 multiplied by 0.0634, and you will get 7.8 here. When you will do 405 multiplied by 0.0634, you will get 25.7. So this is done. Now calculate the mug's average initial horizontal and vertical velocities during preceding time interval and record in lab data to the 1 decimal place. So now for this average initial horizontal velocity for this thing, how we will find it? I can write it. So this is going to be your delta x, the average velocity formula. Average velocity is going to be delta x over delta t. So this delta x over delta t, what does that mean? Means delta x is x2 minus x1. So x2 we have, the second position is 7.8. The first position is 7. And then with the time, t2 is your 0.2338 and this minus 0.167. So when you will calculate this, I got the value v of x as 12. And make sure you need it for the 1 decimal place. So whatever you are getting, make sure you take it to the 1 decimal place. Same we are going to do for the vertical. You have y1, y2, t1, t2. So that is going to be delta v over delta t. And when you will calculate that, because it's going to be 25.7 minus 25.9, you will get a negative value. So I got -3. So this is what we did in phase number 3. I hope this is helpful. If you have any questions, please feel free to reach out to me. And thank you so much.